Good morning students. In today's session, let's discuss about one of the important topic, that is acid and bases. Okay. So actually this is one of the important topic which comes mainly under inorganic chemistry. So to explain what are acid and bases, we have several theories. Okay. Those are Arrhenius acid base theory, Bronsted-Lowry theory, and one more is a Lewis acid-base theory. Now let's discuss the first one, that is Arrhenius acid-base theory. Now according to this particular theory, it says that acid is a substance which produces H plus ions in water. So if at all H plus ions are produced in the water, in that situation we can call that as a acid. We have an example, that is HCl. So here if at all we take a HCl, if it is dissolved in the water, in that case HCl will be dissociating into H plus ion as well as Cl minus ion. So here, as we clearly make out here, since H plus ions are produced in a solution, we can call this hydrochloric acid as a acid. Okay. Now let's see what are bases according to this particular theory. So here, according to this particular theory, base is a substance which produces OH minus ions when dissolved in a water. For example, sodium hydroxide. So we know its formula is NaOH, isn't it? Now, when NaOH is dissolved in a water, it will be dissociating into Na plus ions as well as OH minus ions. Since OH minus ions are produced in the water, we can call this particular species as a base. Okay, so apart from this NaOH, we can also have some other example like KOH, calcium hydroxide, etc. Now, whatever this theory is there, it's simple actually. It says the acidic and basic nature when the substance is put in a water, isn't it? Now, therefore, this theory has its own limitations. Okay, so one of the important limitation is this theory applies only in aqueous media. That is, when the substance is put in aqueous media, in that situation only we can tell whether the species is a acid or whether it's a base. Therefore, it is unable to explain the acidic nature of some of the substance like silica, as well as it's unable to explain the basic nature of some of the substances like ammonia, etc. Okay, so these are the important limitations of this Arrhenius acid base theory. Okay, now let's switch on to the next theory, that's a Bronsted-Lowry theory. Now this theory is there, no, it's actually explains the acidic and basic nature based on proton transfer. Okay, proton means H plus ions, correct? No. Now let's see what is acid, what is base according to this theory. Okay, according to this theory, acid is a substance that donates proton. The one who gives the proton will be called as a acid. For example, hydrochloric acid, HNO3, sulfuric acid, etc. We know that these are capable of providing the protons, correct? Now, let's see the next one, that is base. According to this, base is a substance that accepts a proton. For example, ammonia. So ammonia, we know that if at all it's treated with the acid, it will take up the H plus ion from the acid. Therefore, we can call ammonia as a base. The one who accepts the proton is a base. The one who donates the proton is a acid. Now let's see with the help of one reaction. So here we have taken HCl and ammonia. If these two are treated, we are getting the product, that is Cl minus as well as NH4 plus. Here we can clearly make out that HCl is giving the proton to ammonia, correct? Therefore HCl will be called as a acid, whereas ammonia is a one who is taking up the proton from the HCl. Therefore we can tell ammonia as a base. Okay, so now since HCl is an acid, when it donates proton, it converts into Cl minus ion. Now that is called as conjugate base of an acid. Okay, therefore when acid loses the proton, it forms its respective conjugate base, whereas ammonia is acting as a base. Therefore it takes up the proton from an acid. Therefore it's converted into NH4 plus, which is called as conjugate acid of a base. Therefore when the base takes up the H plus ion, in that situation it's converted into conjugate acid. This is how conjugate base from an acid and conjugate acid from a base is going to be formed. Okay, therefore Cl minus is a conjugate base of HCl and NH4 plus is conjugate acid of ammonia, that is NH3. Now let's see what are conjugate acid base pairs. Okay, now an acid base pair differ by one proton is called conjugate acid base pair. So in between acid and base pair, if there is a difference of one proton, in that case we can call that as a conjugate acid base pair. For example, in the above reaction itself, we have HCl ion which is going to convert into Cl minus ion after proton donation. Therefore, here HCl and Cl minus ion, if you compare, we can clearly make out that they are differ by one proton, isn't it? Therefore, we can call HCl and Cl minus ion as a conjugate acid base pair. Similarly, we have one more pair here, that is NH3 and NH4 plus. If you see these two species, these two also differ by one proton. Therefore, ammonia and NH4 plus are another conjugate acid base pairs. Okay. Now, this theory is also having its own limitation, like it is unable to explain the acidic nature of some of the substance like silica, so on. Also, this theory is unable to explain the basic nature of some substance like NaOH, etc., which are incapable of accepting the proton. Okay, so since this theory is mainly based on proton donation and proton acceptance. Now let's go for the next one. Substance are able to act as both acid and base depending on the reaction. For example, water. So such species will be called as amphoteric species. Amphoteric species. Okay, so they will be acting as both acid as well as base depending on the reaction condition. Water, we know that if it is treated with the HCl, water act as a base. If at all you are treating the water with the ammonia, in that case water act as an acid. Therefore, depending on the situation, either water can accept the proton or water can donate the proton. So such species will be called as amphoteric substance. Now let's switch on to the one more theory, that's nothing but Lewis acid base theory. Now this theory, whatever is there, no, it's majorly based on electron pair acceptance and donation, whether the electron pairs are accepted or whether it's given. Based on that, we have Lewis acid base theory. So simple definition we have here. Let's focus on that. According to this theory, acid is a substance which accepts electron pairs. Okay, so the one who takes the electron pair is an acid. Simple, correct? No? For example, boron trifluoride. So boron trifluoride is one of the species which is actually electron deficient. Therefore, it can easily take up the electron pairs to satisfy its octet. Therefore, we can tell BF3 is a acid. Whereas one more we have, it's a base. Base is a substance which donates electron pair. So base means the one who gives the electron pair. For example, ammonia. So we know that ammonia is the one in which nitrogen is having the lone pair of electrons, correct? No? Therefore, those lone pair can be given easily to the one who can able to accept it. Therefore, we can tell ammonia as a base. So therefore, if at all we are treating the BF3 with the ammonia, in that situation, ammonia is the one who gives the electron pair and BF3 is the one who takes the electron pair. So BF3 is acid, ammonia is a base in that situation. Okay. So by the combination of Lewis acid and Lewis base, we are going to see the formation of the adduct. Okay. Now thus whatever the theory is there, that's also having some of the limitation, like it won't explain the acidic nature of HCl, sulfuric acid, etc. In the same way, it won't explain the basic nature of calcium oxide, NaOH, etc. So these theories are some of the important theory, but these also having its their own limitations. But when we are talking about acid base theory, we have acid base concept, we have to collectively know, we should know collectively about all these theories. Based on that, we can tell whether the substance is an acid and or whether it is a base. Okay, so thank you all for your listening.